9, Day 2, Tangent, Lines, Chords, and Arcs. Alright, so let's do some reviewing. A major arc, okay, is an arc that's greater than 180 degrees and it's named by 3 letters. A minor arc is an arc that measures less than 80 degrees and it's 2 letters. So let's take a look at this image. Arc AD right there is a minor arc. It's less than 180. Okay. Arc ADB is a semicircle. Okay, just to point out, the letters A and the letters B make a diameter, so you know that is a semicircle. Arc ABD is a major arc because it's over 180 degrees. Now, let's look at this, the arc addition postulate. If we add, for example, arc AD plus arc DB, it equals arc ADB. Okay, so it's basically piece plus the piece equals the whole thing, which we've covered before with segments. All right, now let's take a look at these examples. You've got, okay, so I'm going to make this clear for you. That's 120. Okay, so actually before I go over this, I want to tell you guys that the central angle, okay, all right, the central angle is the same as the arc measure. Okay, so definitely an important thing to keep in mind. I'm going to put that in a cloud. And then I'm going to say this to remind you, center, same. Okay, so say that, center, same. All right, so if this is 120 degrees, you know that arc is also 120 degrees. And if this, it says, find the measure of arc ADB, follow the thing. So if this is 120, and this is 60 because this is a linear pair, right? They have to add up to 180. Arc ADB would also be 120 plus 60, so that equals 180 degrees outside. So this is 180 degrees outside. All right, let's do this one. If this is 120, we just covered this. This is 60, and then the rest of the circle, right, would be 180 because that's a semicircle. All right, so you would have to go to D to B to A. So what you're adding is 180 plus 60. That gives you 240 degrees for that arc. Okay, so go ahead and try this problem, okay? Next thing, let's do the chord theorems, okay? First thing I want to let you know is I've drawn these out, so if you want to pause the video and copy, go ahead and do that, okay? So, it says here, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So here, if we say for this picture that that chord AB is congruent to CD, then you know that arc AB is congruent to arc CD. Simple as that, okay? The next theorem, if the diameter or radius is perpendicular to the chord, then it bisects the chord and its arc. Okay, so looking at this picture, I know it's a little bit complicated, but take the time to copy it. I'm going to break it down for you here. If so basically it bisects the chord. So now AF is congruent to BF, okay, and therefore arc AH is congruent to arc BH. Okay, on the other side, right here, you know that because they're perpendicular, CG, okay, is now congruent to segment DG, and CI, arc CI is now congruent to arc DI. Okay, so there's that theorem. The final theorem is that 2 chords are congruent if and only if they are equidistant from the center of the circle. So here, when you look at this, okay, EF is congruent to FG. So I'm going to put that. EF is congruent to FG. And what happens with that is that because they're equidistant from the center, arc AB is now congruent to arc CD. Okay? Alright, let's take a look at this example. Guys, this is all about matching, so don't let it freak you out. Okay? Alright, so we're just basically matching. So, arc PQ goes with arc NM. Okay? Segment NO lines up with segment MR. Okay? Arc NP, okay, right here, okay, arc NP lines up with arc MQ. So basically matching. Go ahead and try 4, 5, and 6. Alright. Here there was just some typo on here. This should have 17 on it. Okay. Now, we should also write in the right angle there. And then I'm going to pull that triangle out. Okay. So now we're looking at the hypotenuse being 17. That being a 90-degree angle. This is 30. Okay. So now that's been bisected. What are you going to do with 30? You're going to split it in half. Okay, so just this part of that triangle is 15. You're going to solve for x. Okay, so go ahead and try that on your own. Alright, the next example is pretty simple. It looks complicated, but it shouldn't be. It says here, DE, right here, this arc is 85 degrees. Okay, now it says find FG. Well, let's look at this. Okay, what would your instincts tell you? It tells me that they are, since these are congruent, right here, it also tells me that this is congruent. So it's simply 85 degrees. Easy peasy. Okay, let's go ahead and turn the page and move on to tangents. Okay. Okay, tangent, remember, touch once. Tangent, touch once. Keep saying that so you remember it. The point at which a tangent line intersects a circle is called the point of tangency. Okay? And that's A right here. Okay? If a line is tangent to a circle, then it is perpendicular and makes a 90 degree with the radius. Okay? So let's do a couple of problems. Okay? So here it says determine if AB is tangent to circle P. All you have to do is make sure that A squared plus B squared does in fact equal C squared, right? So let's compare values. 8 squared plus 15 squared, is that equal to 17 squared? Okay, so yes, it is equal, and that is Pythagorean triple. So yes, AB is tangent to circle P. For this one, okay, this piece is missing, all right? So now what I suggest that you do, if this whole thing is 14, well, what makes up with 14? 5, and this becomes 9, right? So the triangle looks like this. So I'm going to pull it out to make it clearer. Okay, so you have this as, I'm so sorry, this is 11. I was mistaken. This is 11 because these are both radii. Okay, so my bad. That's going to be 16. This is going to be 14, and this is going to be 11. Can you guys check if that works for a right triangle? So, is it a right triangle? Okay. And now, simply here, this is a little bit different. Now you're solving for x. Okay, so I want you to try 7 squared plus 19 squared equals x squared. Okay? X equals, and go ahead and try number 4 on your own. So, try those problems. The final one I call the ice cream cone rule. Okay, so that's what I'm going to write here to remind myself. It says if two segments from the same exterior point, okay, so basically both these segments start from this point and are tangent to the circle, then they are congruent. Look, so again, to have a proper ice cream cone, you want both these things to be congruent, okay? So easy peasy, you're just going to set this up, x squared plus 2 equals 11, okay? So that's pretty easy. All right, I'm going to help you work through this, give you a freebie. X squared equals 9, so you square root, x is 3. Okay? So, go ahead and try number 2 on your own. All right, let's do this final example together. All right, I'm going to match colors to make this easy. Okay, so here's one ice cream cone. Okay, so that's 16. So this is 16. Okay? And then, if this is the other ice cream cone, if that's 9.5, this is 9.5. And then I'm going to color this ice cream cone. Okay, so if that's 11, that's 11. Go ahead and answer this. Find the perimeter of triangle DEF. All right, those are the notes. See you in class. Please don't